Hello, I'm Roger Smith, research scientist in robotic surgery and simulation devices. And I'm doing a session at Florida Simulation Summit about advances in robotic surgery and the simulators that we use to give training on those devices. I've worked with every single robotic surgery simulator that exists, and I think I know where we need to advance and what kind of technologies we need to bring forward for the new world that we are entering. So today, there are over a dozen surgical robotic devices approved for use in the United States. There are also over 100 that are still in the research and development phase. They're trying to create an assistive robotic device for every single surgical procedure that you can imagine. And if we're going to use simulators to train those surgeons, we're going to have to bump up our game. We're going to have to improve some of the technologies we've relied on for a decade. In this short summary, I'm going to talk about 3 of them, and there'll be more in the presentation at the conference. So the first one is realistic physical and digital tissue. The physical tissue that we use today is typically some silicone or water-based product. And our digital tissue are 3D models that live inside of a simulator. Both of those currently are just barely good enough to train with. They look right, and they can do the right thing under a very limited set of conditions, but they're not realistic representations of human tissue and human organs. And they don't behave right when you cut them or pull them or try to knot them and tie them and things. So we're going to need to create digital twins of the human body that are just as good as all the digital twins that we've been creating of aircraft and vehicles. A second area is embedded intelligent tutors. We've seen that the latest advances in artificial intelligence with large language models and deep learning have created software that can consume and summarize and respond to an enormous corpus of data that exists on the internet. It doesn't have to be explicitly programmed in the way that old intelligent tutors and old expert systems had to be. So I think we can use those to create systems that provide guidance and correction and assistance in a more realistic and in-depth way, something we've not ever been able to do before. And then finally, there are performance metrics that are really meaningful in improving a student's performance. For example, most of the metrics that simulators collect today are the things that are easy to measure, not the things that are most important to measure. They look at things like the distance moved or the number of seconds that elapsed, or the things that were explicitly touched or cut that weren't supposed to be. But they can't see the level of confidence and steadiness that a surgeon under training develops as they get better. Those are things that a human instructor watches and comments and teaches on, but that our simulators have never been able to capture when you're working alone. So come and join us at the Florida Simulation Summit, where you can learn so much more from all of the talented professionals who are going to be there.